Hi everyone. Now it's time to grab your convex mirror little packet. Okay. Now convex mirror has another name, just like our concave ones. It's also called a diverging mirror. It diverges light away. Now you see these all the time. Again, if you notice here, I already put on the back of your mirror for you. You see these all the time. These are in the hallways. These are in convenience stores or at the back of all kinds of stores so they can see what's going on in the store. So just like we did with our concave ones, let's start with parallel rays of light and talk about what happens to parallel rays of light when light hits it. So I'll take a parallel ray of light, go on across here, and mine's got a little squished because I cut it not so great. So if I take a parallel ray of light that's going towards the mirror like so, there's your incident ray, it will reflect up and away. So it spreads out the light. And then if I take another ray, I'll draw one down below. It's going to go towards the mirror. And it's also going to spread out light. This one is going to spread it out, but it'll go and reflect downwards. Now, you'll notice that, like, if you remember from a concave mirror, those reflected rays met at that point called the focal point. Well, you'll notice that's not going to happen with this ray or this ray. But if you look at their reflected rays and you trace them back, hopefully I drew mine pretty well here, you'll notice that they look like they met at a point. So this is where our focal point is actually located on a convex mirror. We call this a virtual focal point. It's not really there, it just looks like the light came from there and met at a location. This will be important when we get to equations. This will become a negative focal point. So remember that, because it's actually on the other side. Now, if we want to write a definition, like we did the other day, we can say parallel rays of light. Oh, let me get it so you guys can see. Parallel rays of light diverge when they hit this mirror. When they hit the mirror, it looks like the focal point is behind the mirror. Okay? Now, oh, and you guys couldn't see any of that I did. I'm sorry. I've got my phone sitting on top of my coffee mug so it stays still. So parallel rays of light diverge when they hit the mirror. It looks like the focal point is behind the mirror. Now, in terms of equations to know, they're the same ones. Okay, so the same exact equations still hold true. 1 over F equals 1 over dO plus 1 over dI. M is still equal to negative HI over HO, which equals DI over DO. Okay? Now, in terms of your rays of light, when we draw our ray diagrams, the rays of light are pretty much going to be the same thing, but instead of reflecting through the focal point, they're going to look like they came from the focal point. That will be the difference. Okay? So I'm going to go ahead and jump into examples here. So let's go to example 1. We'll still have the same descriptors. So ray 1, and I'll try to always draw these in the same colors. I'll go red first. So it's still going to be parallel to the axis. Okay, now, normally we say it reflects through the focal point. Obviously, light can't hit that focal point, but it'll reflect as if it came from the focal point. Like so. And we'll trace that reflected ray back. Now, the second ray, we always drew through the focal point. Well, obviously, you can't get to the focal point, but we're going to draw ray 2 in green here. And ray 2 is going to look like it goes to the focal point. Obviously, it can't get there because the mirror's in the way. It looks like it would hit there. And then what it'll do is it reflects back parallel, just like our ray from our concave mirror. So again, the first one is parallel, reflects as if it came from the focal point. This one goes towards the focal point, reflects parallel. We're going to trace that reflected ray back, that parallel ray. Now the last ray is exactly the same. Goes to the center of the mirror and reflects back at the same angle. So it's going to hit here. Okay, the same angle. Again, you estimate. You can start to see where they intersect right here. That'll help guide where that direction is. There's ray 3. Trace it back. Mine got a little off there. Okay, it'll be like so. This should be a dotted line back here. Now, you'll notice that these 3 reflected rays, this one, and this one, never meet. But if you trace them back like we did, it looks like they met back here. Right back here is where your image is. Now, we talked about it yesterday. It's not really there. Normally I draw it as a dotted. It's just really small, okay? Now we have our 3 descriptors. Remember, our first question is always, is it real or virtual? The light rays actually don't meet here, so we call this a virtual image. So that's the answer to A. Okay, and again, I'll move this over. That's a virtual image. It is smaller than the object. That's answer C, sorry. And then it is upright compared to here. So think about all those mirrors that people use in the shopping centers. Their images aren't really there. They're all upright and they're smaller so they can see lots of things going on in the store. Now, what I'm going to do is I'm going to stop this video to make sure it's not too big, and then I'll put one more video up, okay?